Everyone. Welcome to AI Talk hosted by E2E Networks. My name is Aarti Sharma and I take care of business development for Maharashtra region, especially the GPU initiative for Pan India and E2E Networks. So the purpose of hosting a webinar to build an AI community wherein the members can benefit from the industry experts. So today we have Adesh Srivastav, who is a CEO and co-founder at Tessellate Imaging, and Mr. Akash Deep Singh, who is a CEO and co-founder at Tessellate Imaging. Today, they will talk about challenges of deep learning in computer vision. So they will be talking about computer vision application in the industry, application of deep learning in computer vision, and so on. So now I request our speakers to take it forward from here. So just update for the Q&A session, there is a section you can see in your screen. You can put on your questions there. After the session, our speaker will answer all of your questions. Thank you so much. Adesh and Akash, please take it forward. Yeah.
Hey, hi everyone. Thanks, Aarti, for the warm introduction.
Yeah, most welcome. Yeah.
I'll just quickly start the screen sharing. Hey, good afternoon, everyone. I hope everyone has been having a great day so far and a great year as well. Let's jump right into our presentation for the webinar. Around 542 million years ago, there was a period of around 20 million years when underwater population exploded. Several researchers attribute this to the development of what has now evolved into the modern day complex visual perception in living beings. This period is referred to as the Cambrian Explosion and supposed to have started off with a very basic pair of photon sensors which were able to just perceive changes in light intensity. Research on image processing and artificial visual perception systems has been going on since storage and transmission of digital images became a necessity. From compression, enhancement to automating object detection and tracking in videos, researchers have surely come along a long way. And we are now seeing real life applications of AI, which were science fiction just a few years back, like Tesla's autopilot system that can practically drive you from your home to your work or to a shopping complex without you having to do anything in the car apart from getting in. Some other applications that have recently come up and have gained a lot of popularity are applications of deep learning in medical sciences. And some of them are performing even better than humans, like breast cancer detection, which was recently released by Google. And robotic arms doing their specific tasks in assembly lines and large manufacturing facilities and sorting facilities. And we are also seeing some really interesting research and applications come up in AI in the last decade. The computer vision industry is growing at a constant rate of about 32% annually and is supposed to be a $49 billion industry by only 2023. With advances in algorithms, data, and hardware, a lot of off-the-shelf solutions available as ready-to-use APIs, as well as project management and lifecycle management solutions, especially for AI projects, have come up in the last 5 or 6 years. But companies and consulting organizations like Gartner and McKinsey suggest that about 40% of organizations and CXOs have still not defined or have put a AI in their organizational strategies and goals. They also predict that the early adopters of AI, especially enterprises, large level enterprises processing large amounts of data, will definitely benefit as compared to the laggards in this space. Um, This is a graph from the AI Index report published by Stanford every year, and it shows the growth in number of research papers in the last decade from practically zero to about 7,500 just in the field of computer vision, a close second to classical machine learning. AI and ML are still a growing field with major advancements yet to come. And we along with other researchers in computer vision and AI feel that this is just the beginning of narrow as well as general AI applications. And as with any other growing technology, AI and deep learning have their own challenges. Uh, our experiences in the past have suggested some of the challenges in deep learning projects that come up while either developing or deploying or maintaining all of these systems. AI systems from the starting have inherently been black boxes, and concerns around transparency, biases, and attribution have surfaced in the last 2 or 3 years. Uh, Other development challenges like troubleshooting, resource limitations and crunches, and lack of standardized testing approaches for AI systems all lead from the black box nature of AI applications. Privacy and safety of deployed AI solutions, as well as data ownership, are also becoming a major concern and a heated topic of debate in the current AI landscape. Advances in encrypted deep learning are something to watch out for. Another thing for businesses to note is that AI development, deployment, and maintenance is very different from standard software life cycles. This poses certain other development and production level challenges, like accurately estimating the efforts required to develop a project or validate an idea, managing the various dependencies for any deep learning project, uh, monitoring and logging the AI systems, which, as we talked about, are inherently black box systems, and experiment management, and so on and so forth. Uh, Our experience working on different projects in the last few years suggests that this is the state of difficulty and business impact of the challenges in AI, the infographic that you see above on your screens. Uh, Tessellate has processes and tools to overcome some of these challenges, like effort estimation uh, by using a standard approach of discovering the problem statement and working with the client to create a proof of concept, moving on to a MVP, and then a fully deployable solution that works in real life scenarios. Uh, Glue code and other dependency management issues. And we keep refining all of these processes and SOPs on our end with learnings and experiences from every project that we do. And our learnings and experiences while developing all of these solutions for companies and real life issues and problems in computer vision, we we we, uh, we came up with Monk, which and using Monk, we are trying to bridge some of the gaps that are prevalent in the computer vision development space right now. Having talked about the computer vision industry and its application in the real world scenario and the growth in the last decade, I would like to quickly introduce Tessellate Imaging and my co-founders over here. Uh, so Me, Akash, and Abhishek, who's our CTO, we've been working individually in the domain of computer vision for the past 7 years. And we've worked with a broad range of imaging modalities like satellite imagery or medical imagery for analyzing brain cancer or lung cancer classification. Our teams have also served clients across the globe and helped solve some open-ended research problems like detecting disguised and imposter faces uh, with a workshop conducted in Triple IT Delhi along with CVPR 2018 and other computational challenges and development challenges in computer vision, particularly with combined with deep learning. Um, and like we talked about in the previous slide, from our learnings in the last few years from doing all of these projects, we bring to you a set of easy to use tools and libraries for developing computer vision applications using deep learning. I'll now hand over to Akash, who will talk about the technical challenges in deep learning for computer vision and how Monk can help address some of these issues. Over to you, Akash.
Thank you, Adish, for getting us acquainted with the state of affairs in the domain of computer vision. Looking at any of the computer vision researches, there are usually three necessary components. First, a large labeled image or video dataset. Second, a training and inference algorithm. The training algorithm requires a scalable neural architecture, which can be tuned to perform a specific task, some of which Atish mentioned earlier. Another requirement is an efficient deployment to process individual or batch of files to generate the required output. Let's check out some state-of-the-art implementations in the domain of computer vision. By numbers, computer vision is one of the highest research topics with applications of deep learning. Let's check out some of the topics inside image classification. Looking at some of the state-of-the-art implementations on widely available datasets such as ImageNet, CIFAR, we find that there is a research paper implementation on efficient nets. Let's look at the code. Checking out the code, we find a TensorFlow-based implementation of efficient nets. Moving on to another research, let's check out an object detection research called CoordNet. This is another neural network implementation. It is also placed as ninth best model for object detection. Looking at the code, checking out the code, we find out a PyTorch-based implementation. Now, if we go inside each of these implementations, we find out they both have their own set of dependencies, instructions, and a process to follow. Coming back, in the two implementations that we saw, they both were implemented using separate base frameworks, TensorFlow and PyTorch. They both had separate set of dependencies and also a set of instruction to follow. Now, what this does is this leads to, as a developer, more time spent in prototyping and experimentation. Also working parallelly on multiple research projects is of immense cognitive load, since it requires you to work with multiple different base frameworks and different researchers. Well, are paid tools an alternative? There are certainly some great off-the-shelf AutoML libraries that allow developers who are faintly acquainted to the domain, solve selected use cases. While most of the available tools cater to transfer learning, there are certainly some that allow you to design neural networks, while others cater to enterprise domain with features like version control and team collaboration. At Tessellate Imaging, having worked on solving bottlenecks for computer vision problems, we progressively developed a set of useful tools that now have taken the shape of MonkeyEye. Our library is a unified wrapper across PyTorch, MXNet, and Keras currently, which means it has its own syntax, which is simple and repetitive. Our toolkit provides the capability to create custom models and switch research between frameworks. Currently, Monk supports transfer learning-based image classification, which I'll explain in the very next slide. We also have state-of-the-art deep neural network-based object detection workflows. We also have custom neural network building and debugging toolkits. And lastly, we have a point-and-click GUI-based approach to deep learning for building computer vision applications. We are also actively working on features such as one-click deploy to cloud, GPU optimizations, image segmentation, GANs, support for multiple imaging modalities, paper to cloud, and many more such features. Let's look into how transfer learning-based image classification can be built using MonkeyEye briefly. What is transfer learning? Well, transfer learning-based image classification is the task of taking a trained deep neural network that performs highly accurately on a large data set, for example, the efficient net that we looked at, and fine-tune it for a custom purpose. For example, a model that can distinguish between everyday objects can be fine-tuned to achieve high accuracies for purposes of clothes or plant classification. Using MonkeyEye, you can create and manage projects and experiments. The workflow ingests datasets where each class of images is inside the respective folders or presented as CSV level dataset. All state-of-the-art backend pre-trained models available within the three base frameworks, PyTorch, MXNet, and Keras, are accessible over a simple API. Since usually deep learning training requires more than a few hours to complete, our library provides access to pause and resume from last checkpoint. You can in fact also finish an experiment, copy that into a new experiment, and resume from the final state. All hyperparameters, custom layers, transforms, optimizers, and activation functions are provided over a simple and easy to use API. You can compare multiple experiments and finally choose the best performing algorithms. You can infer on single or batch of images and generate test accuracies. We have in fact shared a host of different blog posts and tutorial notebooks on how to create different applications using image classification and widely available datasets. You can follow these tutorial notebooks and the blog posts to build your own applications. With Monk, you also have the power to build a custom neural network. For example, if you want to build your own inception or ResNets, you can design your own custom network using Monk syntax, which becomes available across all the base frameworks. So for example, if you have a ResNet block, you can access that block from all the three base frameworks while combining and attaching multiple such blocks to build your own custom neural network. Let's briefly look into how you can do so using Monk. So here in this notebook, we'll try and implement an inception block. As you can see, this is the structure of an inception block. Our notebooks are quite comprehensive, so you can begin right at the step of setting up Monk. You import all the necessary functions. As you can see, there are 4 branches in the inception block. You create each of these branches using an easy-to-use syntax, defining the convolution layer, the normalization layer, and the activation functions. Finally, once you have all the branches defined, you can combine them together to build your complete inception block. Monk also helps you debug keeping cognitive load low by helping you not to enter shapes of layers or the functions being used, so that in the end MonkeyEye in the backend compiles the entire network and automatically suggests the shape of each layer and builds your network. Finally, you can run data through this custom designed network. You can in fact also visualize it using a very great open source tool called Netron. And finally, this custom neural network can be accessed using any of the three base frameworks that you want, either from MXNet, PyTorch, or Keras. Let's move on to object detection. Current object detection workflows are compute intensive. Our toolkit supports GPU-based training and inference currently. We are actively working towards adding more efficient workflows to support CPU. State-of-the-art object detection workflows are provided with easy to set up, load, train, and infer in the same syntax. Different implementations give access to different knobs that can be tuned to improve performance. As you can see, these are the available object detection workflows, each with their own set of dependencies in an easy to set up and utilize workflow. If you are new to the domain of object detection, you can follow some of our blog posts and tutorials. We have prepared a host of applications and Jupyter notebooks of how to create an object detection model. We in fact also have created notebooks on how to fine-tune each of the knobs available within each of these workflows. So for example, if you want to utilize efficient detection, we have utility notebooks to format your ground truth. We have notebooks to actually build an end-to-end application, for example, low light object detection or traffic sign detection. We have examples such as indoor object detection, billboard detector, face detection, which we constantly share and keep on contributing to the community. One last thing that I want to show is we have integrated every feature accessible from each of the three individual backend frameworks, and we are actively working towards integrating new and latest features, making the library more accessible. Finally, in an attempt to enable programmers and developers from other domains to access deep learning-based computer vision, we have created a point-and-click interface using which the entire suite of programmability and tuning is available in a simple point-and-click user interface. The workflows come with default recommendations depending on the application and backend in use. Let's quickly go over an image classification demo of how to build an image classifier using our point-and-click interface. So as you can see, you can create a new project, you can create a sub-experiment, select a backend. The entire setup is just using point-and-click operations, so you don't have to worry about setting up dependencies on your environment. There are multiple options available of selecting the pre-trained network. You can choose to train your networks, you can set the number of epochs. Finally, during training, you get a plot of validation and training losses and accuracies. And once the training is complete, you can infer on a single or batch of files to generate predictions. So Going ahead, we are planning to add more state-of-the-art research works as ready-to-use workflows, more features such as one-click deployment to cloud, optimization to support embedded systems deployment, integration with the latest TensorFlow 2 library, and much more is in store. We are constantly creating blogs, tutorials, and content to make the library more accessible for all computer vision enthusiasts. We also plan to host hackathons and slowly evolve into a budding place for discussions. We have utilized state-of-the-art implementations and researches and created end-to-end applications. Along with how to create these applications, we have shared Jupyter notebooks on how to do that. These applications are created on readily available datasets online. However, they do have the limitations of that they cannot be used commercially, which I truly believe is one of the limitations of this domain, not having access to datasets that can be commercially utilized. Well, for programmers looking to enter the domain of computer vision, I would like to advise that for beginners, you should definitely stick to a topic of research, starting out by carrying out an in-depth first introduction into how algorithms can solve a real-world computer vision challenge. Given that within computer vision itself, there are a broad spectrum of imaging modalities ranging from satellite imagery down to microscopic slides, selecting a data source not just helps improve your knowledge of that domain, but also teaches you a bunch of useful computational tricks to work your way into building a complete application. Some of the rare lectures that I would like to suggest are on image processing and computer vision. The Ancient Secrets of Computer Vision is the lecture series created by the creator of YOLO. Finally, I would like to mention that we are looking for enthusiasts of computer vision to join us in creating a unified structure for going ahead. I would love to reach out to researchers, programmers, and developers of computer vision and deep learning applications to try out MonkeyEye and help us build an efficient and effective library. Feel free to reach out to any of our social media channels. Thank you. Aarti, if you could take it forward from here.
Yeah, thank you so much, Adesh and Akash. There might be some questions in Q&A section. Yeah, there is one. I hope you can see Adesh and Akash, the question.
Yes, we are
Yeah,
able
okay.
to see the questions. So Smita has asked, is MonkEye open source? Yes, Smita, Monk is open source. You can go to our GitHub repository and fork or download or clone the repository and start using it on your local system or Google Colab or AWS, whatever is your choice of servers for processing deep learning. Akash, you want to take the question from Preeti Dev?
Sure. What if some use case of OpenCV could be done with simply through IoT sensor? Well, of course, another one of the questions in the line is any use of AI and ML in robotic process automation. Well, if you look at artificial intelligence and application of deep learning algorithms, that pretty much surmises process automation in different fields. Wherever human sensors or human insight is required, we are trying to automate that with algorithms and data. Definitely, IoT sensors provide you the right inputs of capturing data. The next step comes into applying deep learning algorithms to generate insights from that data. OpenCV is a computer vision library. The IoT sensor that I believe can be connected or integrated with OpenCV would be thermal or RGB cameras. So yes, there could be certain use cases with OpenCV and IoT sensors, and within robotic process automation, from monitoring workflows or shop floors where manufacturing processes are carried out, to latest applications, for example, monitoring cloud kitchens where chefs are cooking your food, and are they adhering to the compliances required? Are they wearing safety hats or not? And are they preparing your food with gloves or not?
Extraction of information from documents, structured as well as unstructured documents, is another application of deep learning in RPA.
How MonkEye surpasses OpenCV? Well, being an open source library, our goal is not, in fact, to surpass a library. Our aim is pretty much to standardize the approach of how deep learning is applied to computer vision. Now, there is another similar question: are you trying to build a wrapper class for Keras, TensorFlow, and Gluon? Yes. In a way, yes. We are creating our own syntax, our own programming language that uses jargons from the deep learning world and applies that to the computer vision domain. Now, using our workflow and our jargons, like I mentioned and described in the presentation, there are three primary components. There is a data set, and you need a programmatic way to access and manipulate that data set. You need a training and inference algorithm, which is basically tuning a neural network architecture, which you can also design with MonkeyEye and tune, right? So there is tuning available. We are surely definitely coming up with some deployment strategies for cloud. If I use MonkeyEye, will it install all the dependencies of on my system? Yes, there are simple, straightforward setup instructions that you can utilize to set up MonkeyEye locally or on cloud environments like Colab, AWS, or in fact also Kaggle. How can we create a model which is extract the images from document? Well, there are definitely certain algorithms that that you could look into. Attention-based modeling is performing quite great in information extraction from documents if you want to look into that domain.
The older approach is a template-based approach for structured documents.
Yeah, correct.
Where you define what piece of information is going to be available in which particular region of the document. The only problem with this kind of an approach is that it kind of limits the documents that it can process before having a template for that particular document in place.
So I believe you're asking in context of the same document information extraction. If you want to check out a really cool startup, do check out Rossum AI, ROSSUM. They have a pretty great templateless structured information extractor if you want.
Question.
Okay, so someone has asked, TensorFlow keeps on updating on the wrapper class, also need to keep changing. Correct me if I'm wrong. Definitely, there are backend updates to different frameworks, and that's the task of as MonkeyEye. Our organizational goals is to keep up with the updates and reforms in the base framework so that developers and programmers don't have to, right? So the entire suite of features are available. So the entire set of optimizers or layers or activation functions are available in MonkeyEye. And in case newer features or activations or optimizers are added to the base framework, we do add that as an API access from MonkeyEye. So can I employ MonkeyEye for a product I might be developing? So another question is, so can I employ MonkeyEye for a product I might be developing? Well, definitely. That's one of the reasons why MonkeyEye was open source. It was to help programmers and developers build their own real-world applications using Monk. and definitely try and sell those.
Yeah, in fact, very recently, one of the recent graduates from VIT Nagpur used MonkEye to learn computer vision and the basics of deep learning and object detection, and that helped him to get an internship in a data science role in a company in Bangalore. Another thing that I would like to point out is we are not. MonkEye is already open source, as we've already talked about, and we are not trying to compete with TensorFlow or Keras or PyTorch. We are just trying to address some of the issues and challenges that we ourselves faced as developers while creating solutions and experimenting with computer vision technologies. And we thought it would be helpful to come up with a library that can address some of those challenges while still allowing developers to use the framework of their choice, be it TensorFlow or PyTorch, and whatever they are comfortable working with. We have another question. I'm learning TensorFlow 2.0, so can I contribute to MonkEye for object detection with TensorFlow 2.0 backend? Yes, precisely. That's exactly what we want from people. We want the community to take up development of MonkEye. Also suggest other challenges that beginner developers entering the field, as well as expert developers and PhD researchers who find any other challenges that are currently not present in MonkEye. And we would like contributors to take charge, as in any other open source frameworks in computer science, not just AI, to help in the advancement of a technology that the community feels is going to be helpful. You can go to our website and drop us a mail if you want to contribute, and we can get you started on a particular track that you are interested in. We have another question. What is the system specification for running MonkEye applications? Is there any such specs?
So for image classification, well, I use MonkEye on my MacBook Air. So I believe it can run on simple CPU-based systems. So if you're looking to build image classification models, you can run on CPU to GPU systems. For object detection, though, we currently only support GPU-based training and deployment. So if you have a GPU-based local system, you can set up Monk object detection workflows locally. Or in case you're looking to develop on cloud environments, you can check out Google Colab and Kaggle.
Okay, we have another question. What size of batches or how many objects can I classify? Like how many test images at a go?
Well, that truly depends on the pre-trained model, the architecture that you're utilizing, the size of the images that you're testing, and that is pretty dynamic, and that also definitely depends on the system that you're using. You should definitely try out Monk. It does give you, the time it takes to train and process batches. So, that should answer your question once you've tried out the library.
Yeah, at the beginning of training, Monk gives you an estimate of how much time it's going to take, the number of epochs that you've set it for, and also has other features like resuming and pausing training and copying experiments across different frameworks, as outlined by Akash previously during the presentation. We have another question from Preeti. Is there any internship related task or projects we can contribute in MonkEye? Yes, definitely there are. If you go to our GitHub page and check out the README available over there, you can see our goals for the next 2 or 3 months. our development goals for MonkEye library for the next 2 or 3 months, and you can pick your topic of choice and talk to us, come up with a plan, and start contributing once your plan has been approved or gone through. It's not necessary to follow just the list that's there. You can also come up with, like I said, you can also come up with any challenges that you've faced or any other libraries or implementations for object detection or classification that you found out and you found interesting. You can also try to incorporate that with Monk. It's always going to be helpful. We also recommend and encourage students and researchers participating and contributing to MonkEye to also write blogs about the features and the updates that they make to Monk to help their own career and visibility on social media, as well as improve the standing of MonkEye currently.
In fact, the founders at Tessellate Imaging are readily available on all social media channels. So feel free to reach out to any of us in case of any queries or doubts.
Um, I think we are done.
Ati, your voice was breaking up.
Okay. Just give me a sec.
Uh, another thing that I just wanted to tell you guys is we'll be sharing the deck, the presentation from the webinar on SlideShare, and Aarti will probably post on social media with all the relevant links for the webinar and the library and tutorials and everything else
Yeah.
immediately after the webinar. Yeah.
Yeah.
Aarti, you can add if I've missed anything.
No, absolutely correct. I'll be sharing all the, presentation and the recording of this webinar in mail, as well as this post on our YouTube channel, so that people can easily go and check it out.
Oh, wonderful.
If they have missed somewhere, right? So yeah, I think we are done here. No questions are coming up. Is there anything else, Atesh and Akash, you want to add up here?
I don't think so. We've kind of talked about everything that we wanted to. Again, we are happy to talk to anyone who wants to work on Monk, contribute at Monk, and in general want some advice about how to enter the field of deep learning, or just wants to have a brainstorming or a discussion with us. We are, like Akash said, we are available over social media, and feel free to reach out to us and discuss anything that you want to about AI and computer vision. We'd be happy to help you. I think that's it from us. Thanks a lot, guys. Thank you for attending.
Thank you so much, Atesh and Akash,
for conducting this webinar and inviting Tessellate to be of any value to your listeners and customers.
Most welcome, Atesh and Akash, and thank you so much for sharing your resourceful knowledge with us. And thank you all the attendees for joining this session with us. I'll share, as Atesh has already mentioned, we'll share the presentation as well as the recording of this session. Right, and next month again we will come up with new topic, with new speakers, something related to AI, absolutely. So yeah, thank you so much, everyone.
All right, I think we have just one more question. Do we want to take that up? I think we have time. We can take it up.
Yeah, absolutely.
Someone has asked how to enter the field of deep learning. Akash, do you want to take this up?
Sure. So yeah, well, if you look at deep learning algorithms, in fact, are a set of mathematical approaches or a set of steps to solving a particular problem, right? Solving a real world challenge or any purpose that you want to apply deep learning algorithms to. Now, as a primary advice to anyone looking to enter the domain of deep learning or signal processing, I generally advise that you should stick to a particular type of signals. So, for example, you can choose audio signals, or within computer vision itself, there are different types of imaging modalities like satellite imagery. Then within satellite imagery, there is multispectral imaging. So there are a lot of signal types that you could work with. Each of the data types or signal types have their own nuances that can be solved with different sets of deep learning algorithms. So working with a single data type or a single signal source helps you focus your area towards a set of algorithms, apply them and try out different approaches for that particular signal. And that helps you learn a lot of computational tricks working your way up, so that as soon as you switch your data type or your signal source, you can actually know all the nuances that have to be carried out when applying deep learning algorithms to a data, and then learn your way up into building large scale applications of deep learning. I understand it's vague, and entering the domain of deep learning and computer vision still does not have a standard pathway to follow. But yes, choosing a data source helps you gather the most important domain knowledge. For example, working with medical imagery helps you understand the kind of questions that are being answered using the data that is available for that domain. All right, that'll be it from my end. So thank you guys. Thanks a lot, everyone.
Yeah, thank you again. Have a nice day.
Thank you so much, Adesh and Akash and everyone.